Yo, what's up, dudes? I decided I'm gonna do these videos in an accent each time, so let me know what accent you want to hear next. What am I today? I'm a surfer dude. Something like that. So you guys know how to turn rational numbers into decimals, or fractions into decimals. We did that last time. And now we're gonna just talk about adding rational numbers. So these can be positive or negative, but now we have fractions and decimals too. So it's going to be a little bit more tricky than in the last chapter because they are not whole numbers and integers like the other ones were. But first let's review what opposites and additive inverses are. So they're opposites if on a number line they're the same distance, but the opposite side is 0. This is a really bad surfer accent, I know. It's kind of a cross between a surfer and like a, I don't even know. So anyway, the 2 points are graphed. And they're opposites because they're both 3/4 away from 0. 3/4, negative 3/4. Oops, went too far. Sometimes I do that. If I add a number and it's opposite, another term for opposite is additive inverse. When we add those, we get 0. So if I have negative 3/4 and a positive 3/4, they equal 0. Now if you want to find the additive inverse of negative 7/8 would be positive 7/8. Good job. So, negative 7/8. Here's how you graph these on a number line. Notice that the number 1 is here, but I have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, which is 1. So if you want to graph these fractions, you got to divide it into however many parts are on your denominator. So here's my original value, negative 7/8. Where would the additive inverse be? Where do you think? Point to it. Did you get it right? Hopefully you did. Okay, I gotta stop this accent. This is really annoying me. So additive inverses. Oh, by the way, this is on page 185. Sorry about that. So at the top of page 186 is a check problem for you to do. So take a second and do that. We're going to skip example 2. I don't really like it. So we're going to skip that. And after you do the check problem, you can go to 187. Learn how to add rational numbers. So the rules we used for integers still applies. A positive plus a positive is positive. A negative plus a negative is negative. We add those together. But when we have one of each, remember that you actually end up subtracting the numbers and then taking the sign of the larger number. And it'll be tricky because sometimes we're going to add fractions with fractions, decimals with decimals, but sometimes we'll have to add mixed forms, a fraction and a decimal, for instance. So the way we're going to do that, we're going to change them both to the same form. So if we have one of each, we'll either change them both to fractions or both to decimals, and then add them together. If they are non-terminating, so if it's something that repeats, like 1/3 is 0.33333, then we want to use the fraction form. So if they're terminating decimals, then we can use either decimals or fractions. But if you have some that are non-terminating, 1/9, 2/3, so on and so forth, you would use the fractional form to add them because we want exact values. So 0.333 you would have to round off and add. So we'll just use fractions when it comes to non-terminating decimals. Okay. Now again, when a fraction is negative, there's 3 different ways we can do this. We can have a negative 2/3, 2/-3, or the negative could just be out front. But if we're adding 2 fractions with negative signs, the sign is usually applied to the numerator. So you can go to page 188, and we're just going to look at a few examples of adding rational numbers. So we'll start with fractions and mixed numbers. With mixed numbers, there's a few ways you can do this. We could actually add, with negatives, I think it'll be a little bit easier if we just change it to improper fractions. So we'll start with that. So we're going to take this mixed number and change it to an improper fraction. Remember that to do that, we take the denominator times the whole number. So 3 times 7, or wow, 9 times 3, which is 27. I'm thinking of the answer at the same time. 27 plus 5 is 32, and then put that over our denominator of 9. And then same thing here, 1 times 9 plus 2, which is 11, and leave that over the denominator of 9. Now remember that to add fractions, we have to have a common denominator, and lucky for us in this case, there is a common denominator. So once the denominators are the same, then all we have to do is add the numerators, and the denominator will just stay 9. So common denominator, add the numerators. So now it's just what we did in the last chapter, negative 32 plus 11. So how would we add negative 32 plus 11? Think about that. One of each, so we actually subtract these two. 32 minus 11 is 21, and since the larger absolute value number is negative, then my answer is negative. So this is negative 21 over 9. And so from this point on, the addition is done. Now we can just simplify. Since these each have a common factor of 3, we can divide the top and bottom by 3. 21 divided by 3 is 7. 9 divided by 3 is 3. Or we can change it to an improper fraction, negative 2 1/3. So the sum of these two is, and you could fill in the blanks on 188, either negative 7/3 or negative 2 1/3. So again, just to change it back to an a mixed number, if it's negative 7/3, then we would do 7 divided by 3 to change this to a mixed number. So there's a remainder of 1, so we'll write that as 1 over 3, so 2 1/3, and then it's negative 2 1/3. So that's how you change from an improper fraction back to a mixed number, in case you forgot. All right, let's look at another example together. So for this one, we want to add these two numbers and write it in simplest form. So our first step is going to be to change it to an improper fraction. So if I'm changing this first one, we'll do 10 times 4, which is 40, plus 3 is 43, over 10, so the denominator stays the same, plus 10 times 1 is 10, plus 9 is 19, over 10. But this is a negative number, so I can't forget to include that negative. So it's 43 over 10 plus negative 19 over 10. And this is not in your book, so on page 188 in the margins, you probably want to add this example and write this down just so you have another example to look at. So now that the denominators are the same, my answer is going to be a fraction over 10 also. And all I have to do on top is 43 plus negative 19. Now, when we have a positive plus a negative, what do we actually have to do? Subtract those two. So this is going to be 13 minus 9, which is 4, and then 3 minus 1, which is 2. So that's 24, and since positive 43 has a larger absolute value than negative 19, then my answer is going to be positive. So this will be 24 over 10. So again, if you're confused on any steps, pause, go back, rewatch it until it hopefully will make sense for you. But you can slow it down and watch step by step slowly over again if you need to. Now if you look at 24 and 10, they each have a common factor of 2. So I could divide each of these by 2 to get 12 over 5. So you can leave your answer as a fraction 12 over 5, or we can change it to a mixed number by multiplying, or by dividing, excuse me. And since there's a remainder of 2, oh my goodness, why this computer's so weird. It would be 2 2/5. Let me see if I can make this smaller. Oh, there we go. Set. There we go. Okay. So either, oops, oh my goodness. Alright, so either 12/5 or 2 2/5 for this one. So you guys pause, and on page 188, right in the middle, there's a check problem, -3 1/6 plus -2 5/6. I'll bring it up here on the screen in case you don't have your book with you. But I want you to try this problem. Put it in your notes or answer it in the book if you have your books with you, which hopefully you do. But I want you guys to try this check problem. So here it is right here. And see how you do. You'll first have to change it to an improper fraction, and then add the numerators, and then simplify from there. Okay, now that you've paused and done that, let's look at example 4 on page 188. So with this one, we have a mixed number and just a fraction. So this one's actually a little bit simpler because instead of having 2 numbers to change, we really only have to change the first number. So I'm going to change this first number to an improper fraction, but it is a little work because we don't have a common denominator in this case. So now we change this to an improper fraction, but I don't have a common denominator. So remember that to add fractions, we have to have a common denominator. So the common denominator is going to be the lowest common denominator of 4 and 6, which is also the least common multiple of 4 and 6. And on page 188, in the top box, you can put the 7/4. But if I want to get a common denominator, what is the least common multiple of 4 and 6? Well, think about multiples of 4 are 4, 8, 12, 16, so on and so forth. Multiples of 6 are 6, 12, 18, and right away we see a number that they both have in common, which is 12. So the common denominator is going to be the lowest common multiple. Okay, so, sorry, I had to do something really quick. But 12 is going to be my least common, my least common multiple. So I need to get both of these denominators to equal 12. Well, think about it. 4 times what equals 12? 4 times 3 equals 12. Excuse me, so I'm going to multiply that fraction by 3 over 3. And what does 3 over 3 equal? 3 over 3 really just equals 1. So I'm just multiplying this fraction by 1. What happens when you multiply something by 1? It stays the same. So we're not changing the value of the fraction, we're just changing the form of the fraction. And here, 6 times 2 equals 12. So I need to multiply the top and bottom there by 2 over 2. So when you do that, then you end up with 21 over 12 and -2 over 12. So now we've created 2 fractions that do have a common denominator now. And now we'll go back to the steps we just did, where now that the denominators are the same, we just have to add the tops. 21 plus -2 is 19 over 12. Positive 19, we subtract the 2, which is the same as 1 7/12. So my answer is 19 over 12 or 1 7/12 is what you can put in those boxes on page 188. So I know it's a lot of steps, but again, it is important for you to learn how to do problems in steps and to work through a problem and to persevere even though it might seem kind of difficult. And even though it is a lot of steps, you need to be able to do hard things and to solve hard problems. And so I want you guys to try hard and try the check problem on the top of page 189. So see if you can do that one. Pause and do that one, the check problem at the top of page 189. And we are going to stop there for now. So enjoy your long weekend. Hopefully you can do some of these fractions, adding fractions, remembering how to add fractions. And if you want, as a bonus, why don't you guys also try this problem, write this one down in the margins, and do this one as well on the top of page 189. In the margins, write this down along with the check problem and try both of those. So that'll be your work for today. Watching this video, doing those couple of problems, and we will check in on Monday and see how it's going and finish, or Tuesday, not Monday, and then finish this section up. All right, have a good weekend.